Hello students, welcome you to this video. So here we are going to continue sums in conditional probability. Okay, so let's see the 8th question in exercise 12.3. One bag contains 5 white, 3 black. One bag contains 5 white, 3 black. Another bag contains 4 white, 6 black balls. If one ball is drawn from each bag, here you draw 1, here you draw 1. So 1 plus 1, totally 2 balls, 1 from each bag, right? Find the probability that both are white. So this is the first bag, this is the second bag, right? Both are white. Please listen. The first one, probability that both are white. What's the meaning of that? From the first bag, you should get a weight. W1 I'm writing, 1 stands for first bag, okay? Weight from the first bag, and from the first one you should get weight, and second one also you have to get weight, right? So from the first bag you are getting a weight. What's the probability of getting a weight? Total balls, total is what? 8. So denominator is 8. But weight, favorable case weight, 5 cases. So 5 by 8 into first weight from the first bag and weight from the second, right? So weight from the second, it is 4 by 10. So you can cancel by 5 table, here 4 table you cancel, so your answer is 1 by 4. See the second subdivision. Second subdivision is both are black. Second one, probability that both are black. What's the meaning? From the first bag you should get a black, and second one also you are getting black. From the second bag also black. First bag totally 8, but in which black balls only 3. So 3 by 8. And the second one totally 10 balls are there. 6 plus 4, 10. We have to get a black. It is 6. So 6 by 10. Again you cancel by 2 table. Here 3 and 4, right? So our answer is 3 3s are 9, 9 by 40. Now let's see the third subdivision. Third one, what they ask, probability that one white and one black. One white and one black. Here actually there are 2 cases. One white, one black. From where you should get white? Nothing mentioned. So white from the first, black from the second, or black from the first, white from the second. In both the cases you are getting one white and one black, right? So you can write it as white from the first, black from the second. R means plus. White from the second and black from the first. Okay. Or you can write in the reverse order. Black from the first and white from the second. White, black, or black, white. You are getting one white and one black. So in the first one totally 8 are there, in which white 5. So 5 by 8. Into black from the second. Second totally there are 10, in which black 6. So 6 by 10. Plus black from the first. First totally 8, black 3. So 3 by 8. And white from the second, it is 4 by 10, right? 4 by 10. So I'm not cancelling. So if you expand it, if you multiply 30, right, by 80. Plus 12 by 80. If you add it, 42 by 80. So denominators are same, so easily can do the calculation. Now we cancel by 2 table, 21 by 40. That's your answer. Now let's move on to question number 9. 2/3 of students in a class are boys. So probability of selecting a boy is 2/3, 2 by 3. The rest are girls. So probability of selecting a girl is 1 minus 2 by 3. So that is 1 by 3. It is known that the probability of a girl getting a first grade. So for that I am giving an event. Let A be the event that getting first grade. So please see what is given here. Probability that a girl, it is given a girl, P of G, probability that of a girl getting first grade I am taking it as A, that is 0.85, and that of a boy. So a boy is given, what the probability of getting the grade is, that is A. A is getting grade, I'm taking like that, okay? So boy, we take B, girl, we take it as G, so it is 0.70. Okay, this is what given. Find the probability that a student chosen at random will get first grade. So probability of getting a first grade. Probability of getting a first grade means it is A. First grade only, you take it as A. So two possibilities, selecting a boy and the selected boy is getting first grade, or selecting a girl and means multiplication. The selected girl is getting first grade. So selecting a boy, it is 2/3, and that boy is getting first grade. Boy is getting a first grade 0.70. Selecting a girl, it is 1/3, and that girl is getting first grade 0.85. So if we simplify, multiply 7 2s are 14. So 1.4/3 plus 0.85/3. So take 3 as LCM, add the numerator 2.25 divided by 3, 0.75 you'll get, okay? Now let's move on to question number 10. Given P of A union B given, the question is find P of B. Find P of B if under some conditions. See, the first condition is A and B are mutually exclusive. A and B are mutually exclusive. Mutually exclusive means, P of A intersection B is equal to what? 0, right? See, so we write addition theorem, P of A union B is equal to P of A plus B of B. That's the last term will be 0. P of A union B 0.7 equal to P of A 0.4 plus P of B. So from here you can find P of B easily, right? P of B is equal to 0.7 minus 0.4, it is 0.3. So this is P of B under the first condition. What is the first condition? A and B are mutually exclusive. If A and B are mutually exclusive, then P of B is 0.3. Second case, the condition is if A and B are independent, then what is P of B? Okay. So second case, the condition is A and B are independent. You know the condition for independent. P of A intersection B is equal to what? P of A into P of B, right? So again we start with addition theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B 0.7 equal to P of A P of A 0.4. P of B we don't know, minus P of A intersection B can be written as P of A into P of B because A and B are independent, right? Bring that 0.4 here, 0.7 minus 0.4 is equal to P of B minus P of A 0.4 into P of B. So left side you simplify 0.3. The right side you take P of B common, you will get 1 minus 0.4. That is 0.3 equal to P of B into 0.6 you will get. So bring it down, 0.3 by 0.6 equal to P of B, or P of B equal to, shift one digit to the right, 3 by 6, you can say 1 by 2, or you say 0.5. Okay, so this is your answer for the second part, if A and B are independent. Now let us see the third one. Third subdivision, you see. See what's the condition now? Third one. P of A given B 0.4. P of A given B is equal to 0.4. So this is the third one. Under this condition, you have to find P of A, P of B we have to find, right? So please listen here. P of A given B, you know the formula. P of A intersection B by P of B, right? Equal to 0.4. Cross multiply P of A intersection B. Here P of A intersection B we don't know. P of B also we don't know. So with this we cannot do anything. So P of A intersection B is equal to 0.4 into P of B. Okay. Now how to proceed? Whenever you have a problem, if you don't know how to proceed, you write addition theorem. Okay. So what is addition theorem? We have P of A union B is equal to P of A plus P of B minus P of A intersection B. Substitute the known values. P of A union B is 0.7, right? P of A 0.4 plus P of B we don't know minus P of A intersection B. You can write it as 0.4 times P of B using the result number 1. Okay. Now we can find it because now we have an equation in only P of B. Bring that 0.4 here. 0.7 minus 0.4 is equal to, take P of B common, you will get 1 minus 0.4. So this is 0.3 equal to P of B into 0.6. Bring it down, 0.3 by 0.6 equal to P of B. So P of B equal to, shift one digit to the right, 3 by 6, 1 by 2, same as 0.5. Now let's move on to the fourth subdivision. Here also you have to find P of B, but different condition. What's the condition in this case? P of B given A 0.5. P of B given A is 0.5. Please listen how to do this. You apply the formula P of B given A. What's the formula? P of A intersection B by probability of denominator P of A 0.5. But now P of A value you know, P of A intersection B is equal to 0.5 into P of A. P of A you know. What is P of A in this case? 0.4. So just to substitute 0.5 into 0.4, so you are getting 0.2, right? So now you can write addition theorem. So we have P of A union B is equal to P of A plus P of B minus P of A intersection B. This is 0.7 is equal to 0.4 plus P of B we don't know. P of A intersection B 0.2. You got it. So bring this 0.4. No, we can simplify like this. 0.7 is equal to, if you simplify these two, P of B write as it is. 0.4 minus 0.2, it is 0.2. Bring it to the left side. 0.7 minus 0.2 equal to P of B. So in this case also, you are getting P of B is equal to what? 0.5. Okay, so under different conditions, how to find P of A, that only we are finding here. Okay, now please listen. The next question is very, very good question. A year is selected at random. Please listen. You are selecting an year. It can be a leap year or ordinary year. So you studied in 10th standard. Leap year containing 53 Sundays, ordinary year containing 53 Sundays, all that things we are going to use here. If I take an year, it can be any of the two, leap year or ordinary year. Leap year 366 days, right? Ordinary year 365 days. Leap year occur once in 4 years, right? So I'm taking, let A stands for ordinary year. B be the event that getting a leap year. Then another event 53 Sundays. C be the event that 53 Sundays. Now please listen here. Probability of, you take an year, what's the probability of getting is an ordinary year. If I take 4 years, 1 year will be leap year, another 3 will be ordinary years, right? So 3 by 4. Probability of B means probability getting a leap year. If I take 4 years, 1 year, if I take consecutive 4 years, 1 year will be leap year, right? So 1 by 4. Now, probability that an ordinary year is given, what is the condition that it contains 53 Sundays. 53 Sundays means C. So P of C by A. Ordinary year means 365 days, right? So how many weeks are there? 5 sevens are 35, balance 1 15, 7 twos are 14, balance 1. 52 weeks, so 52 Sundays will be there, and the remaining one day can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? Totally 7 cases, but favorable case Sunday, only one case, so it is 1 by 7. Then probability that a given leap year, what is the probability that the leap year containing 53 Sundays? So 366 days. So 52 weeks and 2 days remaining. 2 days remaining means the 2 days can be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Here also 7 cases, but Sunday in 2 cases. So your answer is what? 2 by 7. So these are the 4 probabilities you remember. Probability of selecting a leap year is 1 by 4. Ordinary year 3 by 4. Leap year, ordinary year containing 53 Sundays 1 by 7. Leap year containing 53 Sundays 2 by 7. Okay, so with this idea, all these we studied in 10th standard. Now the first part, what is the probability that it contains 53 Sundays? You are taking a year in random. What is the probability that it containing 53 Sundays? That is, you find P of C. So 2 cases. One is you select an ordinary year and that selected ordinary year must contain 53 Sundays. Or select a leap year and the selected leap year containing 53 Sundays, right? P of A is 3 by 4 and that ordinary year containing 53 Sundays, 1 by 7. Selecting a leap year 1 by 4 and that leap year containing 53 Sundays, 2 by 7. Don't cancel anything. 3 into 1, 3 by 7 fours are 28, plus 1 into 2, 2 by 28, so your answer is 5 by 28, right? So this is the answer for the first part. Now let us see the second part. See what they asked here. It is a leap year. It is a leap year. You are selecting a year. What is the probability that it is a leap year which contains 53 Sundays? So selecting a leap year and containing 53 Sundays. It is a leap year and it contains 53 Sundays. So first you have to select a leap year and the selected leap year must contain 53 Sundays. 53 Sundays are taken as C, right? Probability of B getting a leap year 1 by 4. And the leap year containing 53 Sundays is what? 2 by 7, right? So you can't cancel anything. 2 table you cancel, right? So your answer is 1 by 14. Okay, now let's move on to the last question in this exercise. It's a very simple one. Suppose the chance of hitting a target by a person X is, so P of X is 3 times in 4 shots. So trying 4 times, he's hitting 3 times. Probability, problem solved, that type question. Okay, he's hitting the target, probability 3 by 4, not hitting 1 minus 3 by 4, it is 1 by 4. By Y is, that is Y hitting the target 4 times in 5 shots, 5 trials hitting 4 times, so 4 by 5. Y not hitting the target is 1 minus 4 by 5, so it is 1 by 5. Probability that Z hitting the target is 2 times in 3 shots. So probability that Z not hitting the target is 1 minus 2 by 3. So it is 1 by 3. See what they asked here. What is the probability that the target is damaged by exactly 2 hits? Probability that exactly 2. So in the previous video I taught only one of them solved, right? Exactly one solved. So A solved, B and C not solved, or B solved, B only solved, or C only solved. Same way here 2, exactly 2. So easy method, you write like this: A intersection B intersection C plus P of A intersection B intersection C plus P of A intersection B intersection C. Exactly 2 of them solved. Here A and B solved. A and B hit, C not hit. Here B not hit, A and C hit. Here A not hitting the target, whereas B and C hit the target. Okay, now in each case, two of them, only two, exactly two hit the target. Since they're all independent, you can write P of A into P of B into P of C bar. Plus second one, P of A into P of B bar into P of C. Last one, P of A bar into P of B into P of C. All the six values you know, right? P of A into P of B. Sorry, instead of A, B, you have to use what? X, Y. X, Y is that you have to use, right? Okay, otherwise you have to first result you have to mention. So here X, Y, Z bar, X, Y bar Z, X bar, Y, Z. So now we substitute the values P of X into P of A. 3 by 4, 4 by 5. 3 by 4 into 4 by 5 into Z bar 1 by 3. Plus P of X 3 by 4. P of Y bar 1 by 5. P of Z is 2 by 3, right? P of Z is 2 by 3. Plus the last one, P of X bar 1 by 4. P of Y 4 by 5. P of Z is 2 by 3. So I'm not cancelling anything. So 3 4s are 12 by 5 4s are 20 into 3 60. 6 by 60. 8 by 60. So you are getting 60 LCM. 12 plus 8, 20 plus 6, 26 by 60. Cancel by 2 table. 13 by 30 is your answer. Okay. So hope you understood all these things. We'll continue the next video.